Ever wondered what that secret ingredient is that makes your favorite apps feel so snappy and responsive? Well, a huge part of it comes down to this really powerful concept called background jobs. Today, we're going to pull back the curtain and see exactly how they make the magic happen.
Oh, you've definitely been there. We've all been there. You upload a photo, you hit submit on an order, or you try to generate a report, and suddenly the entire application just freezes up. You get that little spinning icon, and you can't click on anything else. It's super frustrating, right?
Well, there is a technical name for that nightmare. Your user interface, the UI, is blocked. It's literally stuck waiting for some long, heavy task to finish before it can even think about doing anything else. And that's a classic sign of a system that isn't really using its resources very well. So here's our game plan for this explainer. First, we're going to pinpoint exactly why your app freezes. Then we'll jump right into the solution, background jobs. We'll look at how they get started and where they actually run. And finally, we'll get into the really interesting stuff, the real-world challenges that make the difference between a simple setup and a truly bulletproof system. Okay, so let's get right into it. Why does an app freeze? It all comes down to when a task that takes a while, like processing a huge image or running a complex order through a bunch of steps, is handled right in the main flow of the application. The UI has no choice but to sit there and wait for that entire process to finish, leaving you just staring at a frozen screen. So the solution is actually pretty elegant. We make the app multitask using background jobs. Instead of just locking up, the application says, hey, this is going to take a while, and it hands that heavy task off to a completely separate process that just chugs away in the background. This frees up the interface almost instantly. And really, that's the whole idea right there. A background job is just a task that runs completely independently of the user interface. The app kicks off the job, and then it can immediately get back to responding to you, the user. From your perspective, it's kind of like a fire and forget operation. So what kinds of tasks are perfect for this? Well, think about anything that's really heavy on the CPU, like intense calculations or things that are I/O intensive, like indexing millions of files. It's also perfect for scheduled things, like those nightly reports that have to run, or really long workflows, like the entire order fulfillment process. You can even use it for processing sensitive data in a totally secure, isolated environment. Okay, so that all sounds great, but how do these background jobs actually get started? The application has to have some way to trigger them, right? And usually it boils down to two main ways. So the two main flavors of triggers are event-driven and schedule-driven. Event-driven is reactive. It happens because of something. A user uploads a photo and boom, that action kicks off the job. On the other hand, schedule-driven triggers are proactive. A timer just goes off, say at 2 a.m. every night, and automatically starts a task, like generating a daily report. And this is the next big question, isn't it? If the UI just fires off a job and moves on, how does it ever find out what happened? How do you know if your photo was processed successfully or if it failed? The communication happens asynchronously. So the UI sends off the job and is immediately free to do other things. While the background job is working, it'll write its status, like processing, complete, or error, to some kind of shared storage, like a database. Then the UI can just check in on that status from time to time to update the user, all without ever freezing. Pretty clever. So these jobs have to run on a server somewhere, but where exactly? Picking the right hosting environment is a really critical decision. It has a huge impact on your costs, how well it can scale, and frankly, how much of a headache it is to maintain. Now, if we just look at a few options from the Azure world, you can see the trade-offs. Azure Web Jobs, they're fantastic if you already have a web app and you just want to run a script alongside it. Easy peasy. Azure Functions are perfect for those short, quick, event-driven tasks. But for total control, or maybe you have some old legacy app you need to support, you might need a full-blown virtual machine. And then for the modern, container-based stuff, container apps are a great serverless option. The point is, the right choice always depends on the specific job. All right, we've got the basics covered. But building a truly rock-solid background job system, that involves solving some pretty tough architectural puzzles. This is really where we separate the weekend projects from the production-grade systems that can handle anything. So here's a classic problem for you. Imagine your app is getting popular, so you scale out your system, and now you have, let's say, 10 different workers ready to process jobs. What happens if two of them grab the exact same order to process at the exact same time? Yeah, you're heading for big trouble. This problem has a name. It's called resource contention. And to fix it, we can use a technique like pessimistic locking. It's kind of like one worker raising its hand and yelling, "Dibs on this order." It puts a lock on it so that nobody else can touch it until that first job is completely done. This prevents all kinds of chaos and keeps your data from getting corrupted. You know, building a resilient system is just non-negotiable. It has to handle restarts gracefully. If a really long job is running, it should use checkpointing to save its progress so it doesn't have to start all over from scratch if there's a crash. It also has to be smart enough to detect and pull out poison messages. Those are bad jobs that would otherwise just crash the system over and over again. And maybe most importantly, your tasks have to be idempotent. So what on earth is idempotent? It sounds like a complicated word, but it's a simple and incredibly powerful idea. It just means that doing the same thing multiple times has the exact same result as doing it just once. So if a job to process a payment accidentally runs twice, an idempotent system makes sure that the customer only gets charged once. It is absolutely fundamental for building reliable systems. Okay, the last huge challenge is scale. What happens on Black Friday when all of a sudden you're getting 100 times the normal number of orders? If your background system can't keep up with that demand, the whole application is going to slow to a crawl. When you're designing for scale, you have to be thinking about auto-scaling, automatically adding more workers when things get busy and then getting rid of them when it's quiet. A key part of this is scaling your background processing power completely independently from your main web servers. And you can't forget, your queues and your databases also have to be able to handle that load, or you'll just create a new bottleneck somewhere else. So, as we wrap this up, here is the thought I want to leave you with. Look, getting a single task to run in the background, that's the easy part. The real challenge, the thing that separates the pros, is building a system that can handle thousands of jobs, unexpected failures, and massive spikes in demand. So the ultimate question isn't just if your jobs are running in the background, it's are they truly built to fail gracefully when things inevitably go wrong?